So the other day I made a video about transimpedance amplifiers for photodiodes. So current sensing, the current generated by a photodiode for light measurements. And I was kind of listening to some interviews and reading about Forrest Mims, um, and he does a lot of like light measurements for things like UV measurements and kind of scientific applications. And he was one of the first people to discover that actually you can use an LED as LED to measure light, as a light sensor. And one of the things he says is that LEDs apparently are much better, they're much more wavelength specific than photodiodes, and they have a number of, their long-term stability is kind of better. So I was kind of interested in trying that out. And he says basically that it's the same kind of deal. And you can stick an LED in where you would put a photodiode and current sense, and it will work. So I put together this circuit to test out, using LED as a light sensor. I upped the feedback resistor, so I'm using 100 meg. Before I was using 100k, so we've gone up several orders of magnitude. So we should be able to sense much lower currents. And the other problem I had is I couldn't, I didn't have a clear LED, and really you don't want a filter over your LED. You just want to use a clear kind of LED for the sensing. So I realised I have a bunch of torches, and this is off a Fenwick EO1, which I keep on my keyring. Yeah, so I just pulled the top off that and then wired it into the circuit to test it out. Yeah, it didn't damage the torch, fortunately. I can just stick it back in. Anyway, this is a circuit, and again I'm using a 741, which is probably not a good op amp to use for this. It's the same transimpedance configuration. So basically any current produced by the LED goes into the inverting input, so the op amp will try and fight against that current, so it will generate a voltage, and which will produce a current going through this resistor to fight against that and to set that to 0. And so that's the voltage that you sense on the output. So yeah, and also, as before, I'm using a split supply just generated from a couple of batteries. So these two batteries are kind of in series, and the ground is set between them to give you a plus and minus 9 volts. So it's kind of tricky to show the thing in the scope at the same time, but just to show that it kind of works. It's kind of interesting because the response is quite slow, which surprised me. But yeah, I'm just using another torch to shine onto it, and you can see, if I get it lined up properly. Oops. Generally, you should put the light off, it kind of helps. It's not going to work. Okay, there we go, now it's working. Problem is, my torch is dying. and you have to shine it right into the sensor. That's with the light shining on the LED, and then if I turn it away, you can see that it slowly goes back. I shine it on the LED, and it's very slowly goes to the rail and back to the rail. And back. So the response time is really surprisingly slow. And I'm not sure why that is, but it is quite kind of interesting. And I guess particularly for the kind of scientific measurements Forrest Mims is doing, you know, the response time doesn't matter. He's just doing daily kind of UV measurements. So yeah. But it works, which quite surprised me.